This is day 8. Today we will continue our discussion of the relationships between arcs and the angles that intercept them. There are 4 relationships that we've learned at this point. And really this is all of them. You need to memorize these formulas because you will not be given these formulas. Again, just to sweep through, if the vertex of the angle is at the center, the angle and the arc measure are the same. If the angle is an inscribed angle, meaning it's at the edge of the circle, the angle is half the arc, or the arc is double the angle. If the angle is inside the circle, but this works even if it's not at the center, is going to be the average of the 2 intercepted arcs. I'm talking about the 2 arcs that go like this. All right, that is x in this situation, and this is y. I messed it up a little bit, but you get the idea. So angle equals arc plus arc divided by 2. It's the mean of the arcs. On the other hand, if the angle is completely outside the circle, then we're going to use almost the same formula, but we're going to subtract instead of adding. So the angle is equal to the big arc minus the small arc divided by 2. So every time you do a problem, you have to stop and ask yourself, wait a minute, which one of these situations am I in? So looking at problem number 1. See if I can zoom in a little bit bigger. Okay, we're supposed to find the measure of angle 1. Look, guys, I don't like calling angles by numbers because it gets confused with the other numbers in a math problem. So hope you don't mind if I use the following system. I'm going to let angle 1 be represented by x throughout this whole video, and I'm going to let angle 2 be represented by y. So with that in mind, we need to find x right here. Let's go ahead and put an x. So the angle, we need to find the angle. See how this angle is outside the circle. That means we're using the 4th formula right here. Big arc minus small arc divided by 2. So I need to know what those 2 arcs are. And here they are. The big arc, okay, see that the arcs change at the point of tangency. So the big arc is this arc right here that goes like this. Okay, that's the big arc. And small arc, I'm going to show it here in green. The small arc goes from here to here. All right, I need to know what those 2 arcs are in order to use that formula. Obviously, I have the big arc. It's 170 degrees. I need the small arc, the green. And I can find that quite easily because the whole circle is 360. So all I really have to do is go 360 minus 170 minus 135, which is 55 degrees. Okay, it's all got to add up to 360. Now I have the 2 angles that I need, the red and the green. So when I go to do the formula, I can just write, I'm going to go back to red, I can just write the angle is equal to the big arc minus the small arc divided by 2. Okay, so I can just put all that in my calculator, and I'm getting 57.5 degrees. Okay, that's number 1. Number 2, we have to find angle 1, which I'm going to call x. This angle is once again outside of the circle. So once again, I'm using this 4th formula. Big arc, angle equals big arc minus small arc divided by 2. So where's the big arc, where's the small arc? I'm going to color it just like I did before. The arc changes here at the point of tangency. So The big arc is this one on the outside here. It's hard to draw with this electronic pen, but I'll do my best. All right, wasn't so bad. There's the big arc, and of course the small arc is just going like this right here. All right, those are the two arcs I need to be able to do this problem, the green and the red. The only number I'm given is 64. This 64 is an inscribed angle. So, looks like I'm actually going to use two formulas. So, looking at that 64, it's an inscribed angle like this one. So remember, the relationship there is the angle is half the arc. Or you can think of it as the arc is double the size of the angle. So that's what's going on here. This green arc should be double this 64. So that means the green arc is going to be 128 degrees. And so that just came from doing that because we doubled it. So we've got the green arc. Now we just need the red arc. Well, look, 360 degrees. The whole circle is 360 degrees. So since the whole circle is just made up of these two arcs, I can simply go ahead and do 360 minus 128, and that should give me the red arc, which turns out to be 232 degrees. All right, now I know the two arcs. I should be able to go ahead and use the formula, the arc minus arc divided by 2. So here I go. That makes this x, the angle equals big arc minus the small arc divided by 2. And I can just put that in my calculator and call it a day, man. And I am getting 52 degrees. Okay, looking at number 3. Same situation. This little angle, which I will call x, is outside the circle. So I'm still going to do that arc minus arc thing. So here's the big arc right here, like this. And here's the small arc over here, like this. Those are the two arcs I need. You can see I've got the big arc already. All I need is a small arc. But once again, we have everything else in the circle except for this missing piece right here. So if I want to find this little guy, once again, I can just do 360 minus everything else. So minus 95, minus 85, minus 175. So I'm just going to put that in my calculator. All right, that little arc turns out to be 5 degrees. No wonder why it's so small looking. Okay, so that's 5 degrees. So those are the two arcs I needed, the 85 degrees and the 5 degrees. So now I can go ahead and solve the problem. All right, I feel like using blue this time. So angle equals big arc minus small arc divided by 2. Okay, I can do that in my head, right? So that's going to be 80 divided by 2, which is 40. So the angle should be 40 degrees. So that's number 3. Okay, let's take a look at number 4. Okay, man, this is next level. This is next level. Well, let's see what I got to do. I can tell at a glance that this is going to be 2 problems in one. So this is really a challenge problem. So watch this carefully. I'm hoping you can see, as formula-wise, can you see which 2 of these situations I have sort of overlapping? Well, the angle is outside of the circle, so that's this angle situation right here. I'm gonna have to deal with that. But then at the same time, you know, the 65 and everything, and have these intersecting lines in here, that is going to involve this formula right here. So I have two problems wrapped up into one problem. Well, let's go in order. So this is what I mean by that. The angle that we're supposed to find here is angle 1, which I'm going to call x. It is outside the circle. So I ask myself, when I do the outside the circle problems, what do I need? I need the big arc and the small arc that are being intercepted. So let's trace that just like we've been doing. So I need, to solve this problem, I'm going to need the big arc, okay, which is 93, I've got that, and I'm going to need the small arc. Okay, if I had both of these arcs, I could do the problem. I'm missing the green arc. So I need to find the green arc. So how do I find the green arc though? Well, to find the green arc, I'm going to have to, and I'm going to go ahead and call that y for a minute. To find the green arc, that's how I'm going to have to do this formula. I can use this situation to find the green arc. Angle equals arc plus arc divided by 2. So here I go finding the green arc first because I need it. So angle, the angle is 65 degrees. So angle equals, so it's like I'm doing this, all right? Angle equals arc plus arc divided by 2. That's what this formula is really saying. Angle, arc, arc. So notice the angle is 65 degrees. I don't automatically put y here because it's a variable. This has to always be the angle, which is 65 degrees. The y is one of the two arcs. So the y is going to go like here. All right, so back down to business. So angle equals arc plus arc divided by 2. So if I solve this equation, that'll give me the green arc. Then I can get back to finding x. So how will I solve this thing, you ask? No, you don't ask that because you already know, don't you? I'm just going to multiply by 2 on both sides, but you knew that. You're pretty smart. So if I do that, those cancel each other out. So this is going to give me 130 over here. So I'm going to have 130 is equal to y plus 93. So then I'm going to subtract 93 from both sides. Okay. So that's going to give me 37. So I have 37. So y equals 37. Okay. All right. That is the green arc up there. So can I squeeze that in there? So this green arc is 37 degrees. That's what I needed. Right from the beginning, I looked at the fact that it was outside the circle, and I saw that I would need the big arc and the small arc. I didn't have the small arc, so I had to do this other formula to find it, but now I've got it. So now I can go back and go ahead and find x using the whole, you know what, maybe I should have left that there. I think I will. All right, angle equals, now that I'm doing the outer one, the angle is equal to arc minus arc divided by 2. And then of course that has to be the big arc minus the small arc. Anyway, here we go. So this time the angle is x. So I'm going to do x equals big arc, all right, shown here in red, minus the small arc, which is 37. We just found that, divided by 2. And that I can just put in my calculator. All right, this is 28 degrees. Okay, that was like two problems in one. That was a little bit more complicated than your average problem, but you're going to run into it, so you better be ready. Number 5 is not looking so bad. So if I want to find this x right here, this is just an inscribed angle. So there's more than one way to do this, but all I need, if I knew this arc, then the angle would be half. But I can find this arc, and let me just color it in. All right, the whole circle is 360. So I can find that red arc by subtracting from 360. So if I just do 360 minus 234, all right, that should give me this red arc right now. So that's 126. So this arc is 126 degrees. Now, when you have an angle that's inscribed like this, all right, and the angle I'm talking about is, of course, this angle right here. That goes like this. All right, this is an inscribed angle. Just like this pink angle is at the edge of the circle, this counts as one of those. So the angle is half the arc. So if this is 126, then I can just take half of it, and that should give me the angle. So that's going to be 63 degrees. Okay, because I divided by 2. So that is how you do that. I'll just put it right here in the middle. X equals 63 degrees. All right, that was much easier than number 4. Uh-oh, man, okay. Number 6 is just like number 4, so I'm going to do it a little faster. In fact, I hope that you are not just watching the video and just watching it all the way through. I showed you how to do number 4. Number 6 is the same thing. So if you have not done number 6 yet, you're watching this video, pause the video. Take out a sheet of paper. Try to do number 6 by yourself. And then run the video and see if you got the right answer. All right, pause the video now. Okay, let's pretend that you paused the video like I told you to. So now I'm going to do the same thing I did before. The angle 1, which I'm going to call x, is outside the circle. So I need to use the formula where we do the big arc minus the small arc divided by 2. So I've been using red for the big arc and green for the small arc, so let me just keep doing that. So those are the two arcs I need. I have the big arc, I don't have the small arc, so I'm going to have to find the small arc. The small arc I'm going to go ahead and call y. Okay, so first find small arc. All right, that's what I have to do first. So how do I do that? Once again, I'm going to use this situation. So angle equals arc plus arc divided by 2. So that becomes angle, which is 93, equals arc plus arc divided by 2. That's the formula. Notice this 93 is the angle always goes by itself here in the formula. And I will solve this by multiplying by 2 on both sides like this. So those are going to cancel each other out. That's going to give me 186. So I will have 186 is equal to y plus 142. You know, I need to move that. All right, that's better. So then I need to subtract 142 from both sides. Okay, so that's going to give me y equals 44. Okay, I'm going to need that. All right, that's not the answer, but I'm going to need that. So remember, that was the small arc. So I'm going to just squeeze that in right here. This is 44 degrees. Now I can go ahead and find the angle by doing big arc minus small arc divided by 2. So that's what I'm going to do. So now I can go ahead and do x equals big arc minus small arc divided by 2. So that's going to give me x equals 49. Okay, 49 degrees. That's how you do number 6. All right. So that was just like number 4, so we just had some extra practice. Okay, 7, 8, 9, and 10 both all use the same picture. Use the information in the given diagram to find the measure. So the first thing I need to find is arc TV. All right, let's look at the picture and see what we got. Okay, arc TV. Arc TV, well, here's T, here's V. So arc TV is this entire thing like this. Okay, that's arc TV. Now, if you're thinking that that's going to be a semicircle, I want you to notice that they did not give us a dot here in the middle. So we, at first glance, we cannot just immediately assume this is a diameter. But actually, it will turn out to be a semicircle. It will turn out to be 180 degrees. But that's because of this triangle over here. This 90-degree angle. If I look at this 90-degree angle, which I'm just going to trace that a little bit better so it stands out a bit. This is a right angle, and it is also an inscribed angle, just like this pink angle. The angle is half the arc. The arc is double the angle in this situation. So if I double 90, I get 180. So arc TV does have to be 180. This is, in fact, a semicircle. So without further ado, TV is 180 degrees. Let's write that down. All right, what about arc SV? Let's see, arc SV. Let's take a look at this. Okay, let me get rid of this for a second. Arc SV, all right, I need a new color. Well, maybe I'll just go ahead and use green. Arc SV goes from here to here like this. Okay. All right, man, this stuff gets tricky after a while. Here's the thing. You see these marks here? I see that arc SV is the same as arc UV. All right, I'm going to need that information, okay? Look here. Man, this is going to be a little complicated. I just don't see any way around it. Let me make my marks a little bigger. Look, okay, focus your eyes on this part of the arc that goes like this. Okay, like from here to here, that blue part of the arc. That blue part is the same as SV. So if I could figure out the blue part, then I would figure out SV. You know what? I want to make that a different color. All right. All right, I decided to go with purple. So if we know this purple part, that'll be the same as SV, which is what we're trying to find. They're marked the same. That's how I know that. The reason why I didn't want to use blue before is because I wanted to save blue for right now. I want to use blue for this arc up here. And I'm talking about the arc that starts here and goes around like this. okay? And I wanted it to be blue because we already are given that angle, and that angle is already written in blue. So this 124 degrees is this blue angle right here. Now, look at the 124 degrees. Look at what it is. Look at the 180 degrees in red. Look at what it is. What would I have to do to find the purple arc? All right, well, I'm really hoping you said, I need to subtract, because that's what you need to do. If you want to find the purple arc right here, all of its purple goodness, if you do the whole 180 degrees, which is the entire semicircle, minus the 124 part that we have, that should give you this purple piece that's left over. So that turns out to be 56 degrees, which means in turn that the green arc is also 56 degrees because they're the same. Okay, so that will also be 56 degrees. Okay, it came from that. Wow, okay, man, these problems are pretty tough. So 56 degrees. So arc SV is 56 degrees, but I feel like I might have blown some of your minds. So 56 degrees. Whew, maybe the next one will be easier. Measure of angle STU. Let's see what that's all about. Angle STU. Okay, that won't be so bad. I'm going to use orange for this one. Okay, angle STU is the angle that I've just shown here in orange, from S to T to U, okay? So just to make it extra clear, so angle STU, we're trying to find that angle. Well, this orange angle here is clearly an inscribed angle at the edge of the circles, like this. So the angle should be half the arc. So this is not too bad. So this angle should be half of the arc that it captures. So it's just a matter of knowing what this arc is right here. And as you can see, let me just delete this arrow for a second. I can just add the two 56s to find that total down there. So, you know, if I look at the total degrees in this area, together this makes 112 degrees. So if I want to find the angle, I'm just going to divide that by 2. Okay, well that's kind of, you know, we doubled it and now we're dividing by 2. So guess what we're going to get, guys? Guess what we're going to get? You're right. We're going to get 56 back again. So this is going to turn back to 56 degrees. All right, good to know. So that's the answer to this one. Angle STU is 56 degrees. All right, so 56 degrees. Last one of this section, angle VWU. I'm running out of colors and space. So hopefully this will be super easy. Angle VWU. All right, to make this problem more clear, to find this last angle, VW, I'm going to do it in pink. All right, angle VWU is like this angle right here, VWU. Remember that angles go forever though, so I'm really going to stretch these out all the way. But it's going to run into the orange and get too confusing. So I'm going to delete all the orange. Okay, I deleted all the orange, and as promised, I took that angle VWU, which if I really just used those 3 letters, I would have just drawn this little piece. But to be able to do the problem, I need to extend. Remember, angles, they go forever. I should put arrows on here. They don't stop. So I can extend these as far as I need to be able to work the problem. So this is the angle that I'm trying to find right now. Notice that this angle goes outside of the circle. So if I want to find angles that go outside the circle, remember that I'm in this situation. I need the big arc minus the small arc divided by 2. So I need to know what are the two arcs that I'm talking about. Now I'm running all out of colors, but I'm going to do this. I'm hoping you can see that the small arc is this arc right here. Okay, I'm just going to highlight it. That's the small arc. The big arc, okay, is going to go from here all the way around like this. Okay, through here, then back to there. That's the big arc and the small arc. Okay, so I'm hoping you can see that the small arc, the 56, I've already got that. So what I need is the big arc, all right, the one that goes out here, so I can subtract. So, all right, this yellow is bothering me now, so let me get rid of that. Whoops. I'm hoping you can see. I can find this piece right here if I want to. Actually, look, oh, semicircle. All right, that's going to make this easier. We have that the small arc is 56. Remember that this is a diameter, you know, TV. We found that this is a semicircle. That's 180 degrees. So, at the end of the day, this is what I really need. Once I remember that this is a semicircle, okay, I'm not going to need that anymore. I'm not going to need this to do this problem. So this is my small arc, the 56 degrees, and now here's my big arc. I'm going to go ahead and draw the big arc in orange. So the big arc goes from here all the way around like this, and all the way back until it gets to the point of tangency. Okay? So those are the two arcs I need, the orange and the purple. Purple I already have. The orange arc is a semicircle. We already found that out. It's the other half of the circle from the 180. So, of course, this is also 180 degrees. So, if I want to find the pink angle, I will simply do big arc minus small arc divided by 2. That's not too bad. Okay, the hardest thing about some of these problems is erasing all the stuff that you don't need and ignoring it. So if I want to find, and I'm going to just call this x again. If I want to find x, it's going to be the big arc minus the small arc divided by 2. And that is going to be 62 degrees. Okay, so that is the answer to number 10. Wait, I forgot to put it down over there. 62 degrees, let me put it over here. All right, number 11. All right, well, this is outside the circle, so we're going to be using the formula that goes angle is equal to the big arc minus the small arc divided by 2. All right, that's the formula that we use when we're outside the circle. So it's just a matter of kind of what goes where. And so it'll be like this. The angle is x. So I need this to be a little bit smaller, and I think I'm going to switch colors. Okay, so here I go. Angle equals. Now, the big arc is 3x plus 17. So I need big arc minus small arc. The small arc is this 2x minus 20. Okay, and all of that needs to be divided by 2. I just put each of these three expressions in where they go. To solve equations like this, I need to multiply both sides by 2 to get rid of the denominator. Alright, so that way these 2's will cancel each other out. So that is going to give me 2x equals 3x plus 17. Now be careful, when you have a negative sign in front of parentheses like this, you need to distribute that, like you're basically multiplying by -1. So this is going to be negative 2x plus 20, not minus 20. Now I'm combining like terms. The 3x minus 2x is just x. Okay, so that's going to give me 2x equals x. And then I've got the positive 17 and the positive 20 is 37. So I've got x plus 37. So, time to subtract x from both sides. So that's just going to give me x equals 37. Alright, that was not so bad. So that was number, what, 11? So, number 12. Alright, number 12 is the same type of thing. Alright, so as we do number 12, the first thing we have to do is look and see which one of these formulas we're going to use. Even though it's kind of weird looking, hopefully you can see that the angle is going outside of the circle. So we're going to use this one over here. Arc minus arc divided by 2. So, in fact, let me just set that up in words for a second. So we're doing the angle, let me squeeze it in over here. Angle equals arc minus arc divided by 2. So I'm just going to put each one of these expressions in where they go. This is the angle right here. And the other two are arcs. That's an arc, that's arc. Oh wait, I messed that up. Ha. That is not the angle. This is the angle out here. Okay, I'm sorry. This is the angle. Of course, these are the same, but this is the angle. The arcs are right here. This is the big arc, because we always have to do the big arc minus the small arc. So this is the big arc that goes all the way around. And this is the small arc that goes like this in green. So we're going to have to do the big arc minus the small arc. So here we go. I'm going to need a lot of space for this. So it's going to be like this. The angle, that's 9x plus 4, that's the angle, is equal to, alright, now I need arc minus arc. The big arc first, so that's going to be 26x minus 5 minus 7x, wait, you're about to make me mess up again, minus 7x minus 2. Kabam. So if I want to deal with the fact that this is a fraction, I need to multiply both sides by 2 like this. So these are going to cancel out. Alright, I have to do the distributive property here. So this is going to make 18x plus 8 equals, I don't need the parentheses now, so I can just put 26x minus 5. But be careful, I do need to distribute this negative sign like multiplying by -1. So this will make negative 7x plus 2. So now I need to combine my like terms. 26x and minus 7x, those go together. And then negative 5 and positive 2. So that's going to give me 18x plus 8. 26x minus 7, that's x. Negative 5 plus 2, that's negative 3. So I have this so far. Now I'm going to subtract 19x from both sides. That's going to give me negative 1x, so I'm just going to put negative x plus 8 equals negative 3. Then I would subtract 8 from both sides, so that's going to give me negative x equals negative 11, which means x equals 11. So that is how you do number 12. Okay, number 13. Which one of these formulas am I going to use? Clearly we're going to do this third one because it's the same situation. So angle equals arc plus arc divided by 2. Whoa, no. So the angle, so maybe I should just write this in words just briefly. So I'm doing this, angle equals arc plus arc divided by 2. Use red now. So the angle is the 9x plus 4. So I'm going to have 9x plus 4. I'm going to have 9x plus 4 is equal to, now the arc plus arc will be the x squared plus 11x divided by 2. When I have a denominator like this, the best thing to do is to multiply by the denominator. Don't forget to distribute this one, but these 2's will cancel out. Distribute this 2, so that's going to give me, switch back to red, that's going to give me 18x plus 8 is equal to x squared plus 11x. Now watch out, you see this x squared and this x. Remember when we practiced doing the quadratic formula? I have a feeling we're going to have to do the quadratic formula for this problem, so watch out for that. First, let's go ahead and subtract the 18x from both sides. Okay? You know what, I'm going to go ahead and subtract the 8 from both sides at the same time. So that cancels out all this. So that gives me 0 equals x squared, let's see, minus 7x minus 8. So we're going to use the quadratic formula. Alright, so it's time to do the quadratic formula. And here it is. If I want the solution here, let me just put a line around this or something. If I want the solution, I need to do I need to know what A, B, and C is, and I need to plug them into this formula. Now, this is going to be quite easy if you happen to know, if you happen to have a TI-30 XS multi-view. So, let's see. The deal is A, B, and C. A is this number that's right here in front of the X. Let's call that 1. So, you know what I mean? This is A, this is B, and this is C. So basically, when I do this formula, I'm going to be doing A equals 1, B is equal to negative 7. Notice the negative sign is part of it. And C is equal to negative 8. So I'm just going to put all these into the formula. Now here's how that's going to look in the calculator. Okay, I wonder, can I make this smaller? So I still would like to be able to see a little bit. Okay, so in the calculator it's going to be like this. Opposite of B. So look, first hit your fraction button. Alright, if you have your TI-30 XS multi-view, hit your fraction button. So we need opposite of B, you know, because that's what the formula says, opposite of B. So B is negative 7, so the opposite of B is positive 7. And then in the formula, next it says plus or minus. We're just going to do plus, we'll do minus later. So plus. And then it has a square root, so square root. And then it has B squared. Now be careful when you do your B squared. When you do a negative number squared, you have to put that negative number in parentheses. So B is negative 7, so I need to put my negative 7 in parentheses. Oh no, what did I just do? Let me start over. So, square root of b squared. So negative 7 squared minus 4. A was 1, so I really didn't have to put it at all. And then C was negative 8. Okay, so you can just type it all in your calculator. Hit your down arrow key, and now we need 2A. A is 1, and again, I didn't really have to put the 1. So there, you could type the entire quadratic formula into your calculator. And then you just hit enter. So you get 8. All right, so one solution to this equation is 8. So let me just put that down. So x equals 8. Now usually to the quadratic formula there will be 2 solutions. And a lot of times in geometry one of the solutions will be extraneous, meaning it would not make sense. Maybe it represents a length and it's a negative number and you can't have a negative length, something like that. So let's go ahead and follow through and find the other answer and see if it makes sense or not. Now, the other answer comes from the fact that the quadratic formula has plus or minus. We did the plus just now, so let's go back and do the minus. Luckily, we don't have to type in this whole thing again. If I use my up arrow key, highlight this, hit enter, now I can re-edit this. So I'll just use my left arrow key to move over until I get to that plus sign. And then I'll just change it to a minus sign instead and hit enter. So that gives me negative 1. Okay, so my 2 solutions are 8 and negative 1. So now I just need to check and see if both of these solutions are valid. So let's erase all this extra stuff for a second. And let's delete this. Okay, so this was the original problem. If x is 8, then that makes this 64. Okay, because that would be x squared. So this would be 64 degrees. So far, so good. If x is 8, then that makes this 9 times 8 plus 4. Okay? So that would just be like this. Okay, so that's 76. Okay, so this arc would be 64, and this angle would be 76, and this arc over here would be 11 times 8, so that would be 88. So that makes sense. Okay, I didn't get any negative numbers or anything. But I can tell that this negative 1 is going to be extraneous. It's going to be invalid because really of this one right here, for example, is the most obvious. If I let x be negative 1, then that's going to make this negative 11 degrees. You cannot have an arc that is a negative number, so that wouldn't make sense. So x equals 8 is the only answer to number 13. Okay, and we didn't really have to do this part that's here in red. I was just checking it out, making sure it made sense. All right, last one, number 14. Let's see what we have here. We've got this x squared. All right, this problem is definitely the most challenging problem on this lesson. And hopefully this would only be like a bonus question or something like that. Just depends on how rigorous your class is. But let's see if I can help you understand this. This x squared is this angle right here. Let me just highlight it for you a little bit better. Okay, this angle right here is your x squared. It goes like this. Okay? Now, let's look at the arc that goes with that angle. Okay? The intercepted arc for that is this arc right here that goes like this. Now, you'll probably notice that this is an inscribed angle. It goes right at the edge. So, if I wanted to, I could do this. I could double it, and that should give me the arc. So if I take this and I multiply it by 2, that means this green arc out here could be 2x squared. Alright, I just doubled it. Wait, this looks like x squared. You know what? I doubled it. I'm just going to say it verbally. So far, so good. Alright, the arc is double the angle. So this is x squared, this is 2x squared. Fine. Now, here is the leap in logic that you need to make. Now, I want you to forget about the red angle for a second. We just don't need to worry about that anymore. Because I need to work my way down here to this expression. So the next thing I'm going to do is look at this angle that goes like this. Let me switch to red. Do this again. All right, now focus your eyes on this angle that goes like this. All right, even though this side of the angle is a tangent, this is still an inscribed angle, just like the last one. So the relationship between this arc and this green angle is still that the arc is double the angle. So that means this angle is going to be half of the arc. So if I take this arc and divide it by 2, that's going to get me back to x squared again. So in other words, this angle right here is x squared. So another way to think of it is that these two angles were the same. Like this angle over here and this angle right here, they're the same thing, x squared and x squared. They're both half of the green arc, so they both had to be the same thing. So fine, this is x squared. Great. Now what? There's still one more leap in logic that you need to make. You need to see that the x squared and the blue angle, this is supposed to be the angle down here, by the way, just to be clear. All right, this 236 minus 15x, that's this angle down here that goes like this. All right, but these two angles are supplementary. Together they form a straight line. All right, so together they form 180 degrees. So I'm going to make an equation that says that these two angles add up to 180 degrees. All right, and that equation is going to look like this. It's going to be, I better make the ink a little smaller. I'm just going to say that this plus this equals 180. They have to add up to 180. So that means x squared plus 236 minus 15x has to equal 180. All right, I know that was a lot. You might have to watch this video over a couple of times if you really want to understand this. But let's keep going from there. To simplify this, this is written sort of backwards and everything, so I am going to do this. So this is the same thing as x squared minus 15x plus 236 equals 180. All I did was I reversed these two to make it be in standard form. So then I am going to subtract 180 from both sides. All right, this is going to be another quadratic formula problem. So if I do that, this is going to give me x squared minus 15x plus 56 is equal to 0. So getting ready to do the quadratic formula, that means a is 1, b is negative 15, and c is 56. So I'm going to put all that in my calculator inside the quadratic formula, which I just showed you on the last problem. Start by hitting your fraction button. B is negative 15, so I'll put positive 15. Let's do plus, and then square root of b squared. So that's negative 15 squared. If you're going to do this on a calculator, you've got to put your negative numbers in parentheses. So there's your negative 15 squared. If you don't put the parentheses, you will get the wrong answer. And that's minus 4ac. There's that 1 again. I don't really need to write that. I'm just putting it to be thorough. And then c, let's see, what was c? C was 56. All over 2a, so that's 2 times 1. And just hit enter, and we get 8. Well, that was just like the last problem. So the answer is probably simply 8, but that's definitely one of the answers, x equals 8. Okay, so let's look at the other one. Now, if I, let's check and see if that makes sense. If I plugged in 8 right here, see this 236 minus 15 times 8? Let's see, you know what, I better not do that yet. I'll check them both later. So far, we only did the plus. So you know when you do the quadratic formula, it's always plus or minus. So we did the plus, so we still need to do the minus. So if we just go up, highlight it, hit enter, then I can slide over till I get to that plus sign. And just change it to a minus sign, hit enter. So I get 7. That's also a nice positive number. So the two solutions to this equation are 8 and 7. Now, let's see if one of these does not work. Now, and the main thing that makes it not work is if you plug it in and get a negative number. Both of these are angles, and you can't have a negative angle, you know, in a geometry class like this. So, if I put 8 here, that's 8 squared, that's 64, that's no problem. Let's see what happens if I put 8 here. 236 minus 15 times 8. Okay, so what did I say? 236 minus 15 times 8. Okay, that gives me 116. So that's fine. On the other hand, if I do the same thing with the 7, well, if it works with 8, it should definitely work with 7. Okay, so it looks like we're just going to have two solutions to this problem. So we're going to have 8 and 7. So that's how you do it, and that was the entire assignment. I know this was a really long video, but if any part of it was helpful to you, then please go ahead and give me that thumbs up, hit the like button. I really appreciate it. And I will see you on the next video.